In this video, we will look at evaluating expressions and functions. By the end of this lesson, you should be able to evaluate expressions and functions for given replacement values and perform the arithmetic operations. So first, let's look at what it means to evaluate an expression. So to evaluate expressions and functions, we have to substitute a number for each variable and perform the arithmetic operation that are given. In our first examples, we're going to evaluate the following expressions. So for number 1, it says 2x squared plus 4y to the fourth when x equals 2 and y equals negative 2. So we're going to take the numbers that we have, the expression that we have, and replace x with 2 and y with negative 2. So that's going to look something like this. 2, if x is 2, I'm going to put 2 in for x, squared plus 4. If y is negative 2, I'm going to put negative 2 in for y, and that is to the fourth power. Notice everything in the pink color is from my original expression. What I put in the other colors is what I substituted into the expression. So now I'm going to evaluate. And for this, I have to remember some of my order of operations. If you don't remember what that is, this acronym might help you for some of this evaluating. So here, parentheses just means I would have to do what's in parentheses first. This doesn't have anything in parentheses, but exponents, that's going to be the important one as we go through this. So we want to do my exponents first. So 2 squared is 4. So I have 2 times 4 plus negative 2 to the fourth power is going to be 16. Now I can multiply. 2 times 4 is 8, plus 4 times 16 is 64. Then I can add. 8 plus 64 is going to be 72. So after evaluating this expression, I get 72. Now I can also do this on my calculator. We're going to use the store button on our calculator. So I'm going to pull up my calculator in just a second, but what we're going to do is we are going to take the 2 and on our calculator, hit this store button and store it as x. And then I'm going to do the same with y. I'm going to take negative 2 and store it as y. So on my calculator, I'm going to take 2, store as x, and I'm going to take negative 2 and store as y. Now I don't have y right up here. We know where x is, but y, I'm going to hit, if we notice on my calculator, I have all these green letters. So I'm going to hit alpha 1, because that's where my y is, and I can hit enter. Now I can just type in my expression. 2x squared plus 4 alpha 1 is my y. To the, that's my little arrow there if I want to make an exponent, fourth power. And when I hit enter, there's my 72. So we stored our values and then we typed in 2x squared plus 4y, and then we had to hit the little caret there to the fourth. And then we got our 72. So you can use your calculator to help you solve some of these as well. Let's look at our second example. Here I have f of x is equal to the square root of 12x squared when x is equal to 3. So here, if we remember, f of x is the same as y. It's the same as y. I have y and I have x. But I call my f of x, this is called function notation. And that's my f of x. And what that means is when I have f of x, I'm going to take my 3 and put it in for x. So I have f of 3 is equal to the square root of 12 times 3 squared. So I'm going to evaluate what's here. F of 3 is equal to the square root of, again, I have to raise it to the power first. 3 squared is 9, is equal to the square root of 108. And if I type that in on my calculator, my square root button, second x squared is my square root button, 108 is about 10.39. So the square root of 108 is approximately 10.39. We can also do the same thing and use the buttons on our calculator. We can use those store buttons again. So for this one, I want to say 3. I'm going to use the store button as x. I'm also going to have to use my square root, which is second, and then the button that says x squared. Second x squared gives me my square root button. Okay, and then to just get the squared, I can use my x squared button. So when I type this in on the calculator, I'm going to clear out what I have. 3 store as x. Second square root of 12x squared. And there's my decimal, 10.39. So f of 3 is approximately equal to 10.39. We're going to take a look at a couple more examples. Let's deal with some other symbols that we're going to need to use on our calculator when we are evaluating expressions. My next one looks a lot like the one I just had, except it has a little 3 here. That is the cube root. That is my cube root. Okay, so when I do this one, same thing. I have the cube root of 12. I'm going to substitute. X is equal to -4. So I'm going to put -4. And y is equal to 5. So I'm going to substitute 5 squared. So again, when I evaluate this, is equal to the cube root of 12 times -4. 5 squared is 25. So if I multiply those numbers together, 12 times -4 times 25, I get -1,200. So I've got the cube root of -1,200. Okay, I'm going to need to do that one on my calculator, again like the square root, but the cube root I need to hit math. And if you notice here at number 4, there's my cube root. I'm going to go down to number 4, the cube root of -1,200. 1,200. I get -0.62. I'm going to round the 6 is going to bring my 2 up. Negative is approximately equal to -10.63. My little equal sign is kind of wavy here because it's an estimate. Again, I can do this on my calculator using that store button. So I can do -4 store as x, and I'm going to do 5 store as y. Other buttons I'm going to use is the cube root. So to get the cube root, I am going to hit math and then number 4 on that list. Okay, so then I'm going to type it in. So I'm going to take -4 store as x, enter. 5 store alpha 1, that's my y, 5. And now I'm going to type in my expression. I'm going to hit math down to number 4, enter, 12x alpha 1y squared, enter. And there's my same thing. So I have the cube root of 12xy squared, when I evaluate it there, is approximately equal to negative 10.63. Okay, let's take a look at another one. In example 4, I have this symbol called the absolute value. The absolute value is our distance from 0, and it's always positive. Okay, absolute value makes anything that's inside positive. Anything that's in those brackets will become positive with absolute value. So let's do the same thing here. I have the absolute value of my x is 1, so I'm going to put 1 in for x, minus 8, and I'm going to put 1/2 in for y, and then my other absolute value bar. They're kind of longer bars than your equation, than your expression there. Okay, so I'm going to simplify that again. So now I have 1 minus 1/2 times 8 is 4. I know that 1 minus 4 is negative 3. And like I said, it makes anything that's inside of it positive. So if that's negative 3, my answer is going to be positive 3. We can also do this one on the calculator. So we're going to use our store button. So I'm going to take 1 and store as x. I'm going to take 1/2 and store as y. And then I'm going to use my absolute value button. So my absolute value button, how I get to that one, I'm going to hit math. I'm going to arrow over, and then I'm going to hit enter to get to my absolute value. So let's go ahead and type that in. So I'm going to clear this off, hit math, arrow over, and then hit enter. If you notice the first one, ABS, that's absolute value. So now I have my bars, and now I can type in what I need to, but let's go ahead and store our numbers first. So I have 1 store as x, and I have 1/2 alpha y equals 1/2 store as y, alpha 1. There's my y. Now I can do my absolute value, hit math, go over to NUM, hit enter, and I can type in x minus 8 alpha 1, enter, and there's my 3. The absolute value of x minus 8y in this instance is equal to 3. And we saw that with our algebra, and we saw that with our calculator. Example 5. I have 2x minus 3 divided by y squared when x equals 9 and y equals negative 5. So again, x equals 9, y equals negative 5. I'm going to substitute in. So I do 2 instead of x, I put 9, minus 3 divided by, instead of y, I'm going to put negative 5, and that is squared. So when I evaluate that, I multiply first. 2 times 9 is 18, minus 3, minus 3. Negative 5 squared is 25. 18 minus 3 is 15, divided by 25. If I simplify that, I can divide both of these by 5. It's equal to 3/5. Again, let's use our calculator. So I'm going to store 9. I'm going to store as x. -5, I'm going to store as y. And I'm going to go ahead and use, if I use a fraction, and this one we've seen before, if I have a fraction, I use alpha, y equals, and then enter. So let's go ahead and do this one. The first thing we need to do is store our values. So we're going to do 9, store as x, -5, store as y, alpha 1. And now I'm going to write my expression. I'm going to do my fraction first. So alpha y equals, enter, 2x minus 3 over alpha 1 squared. There's my expression. I'm going to hit enter, 3/5. So my expression of 2x minus 3 over y squared, when y is -5 and x is 9, is going to give me that 3/5. The same thing I got when I evaluated it up here. We're going to do one more example. And this one we see that function notation again, but this time it just says find f of 7. So in that case, it's just like the one that we did earlier. We're going to do f of 7. So I'm going to substitute in 7 for x equals 2. Instead of x, I write 7, and then I'm going to square it, plus 5 times 7 plus 3. So f of 7 is equal to, remember I have to raise it to the power first. 7 squared is 49, plus 5 times 7 is 35, plus 3. So f of 7 is equal to 2 times 49 gives me 98, plus 35, plus 3. And lastly, I'm going to write f of 7 is equal to my total of 136. So again, let's try that on our calculator. So here we're just going to take 7 and store as x. That's what we're evaluating for. If it says f of 7, that's going to be what we're storing in. And then I'm just going to go ahead and type that in. We've already talked about all of those symbols. So clear out, 7 store as x. And I'm going to type 2x squared plus 5x plus 3, enter, and there's my 136. So f of 7, when we did it on our calculator, we got the same answer of 136. Okay, so these are just some different ways that you're going to be asked to evaluate an expression or a function. There are more problems on your notes that have to do with adding and subtracting polynomials. We will work on that together in class, so please make sure you bring your notes completed to class and we will work on some more examples together.